Hello everyone, thank you for joining me at DevSecOps 2024 by Conf42. In this talk, we will be discussing about software bill of materials, aka SBOMs. But before we dive into the topic, let us get the introductions out of the way. My name is Safir. I have been in the SRE and DevOps domain for past 19 years. I'm an author, speaker, and an ambassador for the Continuous Delivery Foundation. Right. So let us then set this case by recapping our understanding of DevSecOps. The DevSecOps framework improves SDLC by detecting vulnerabilities throughout the software development and delivery process. It merges the security into DevOps practices and shifts the security left. So what are the benefits of DevSecOps? You can catch the software vulnerabilities early, ensure that you have regulatory compliances, build a security-aware engineering culture, and develop new features securely. When we're talking about security in SDLC, a key concept we should learn about is software supply chain. Now, the term supply chain refers to people and process for making and distributing a product, typically applied to manufacturing. In the context of software supply chain, it includes people, process, and software components that touch your software development life cycle, starting from the source code all the way up to your software deployment. Now, what makes software supply chain special? Almost no modern software products are built from the ground. They are always built on top of existing software, predominantly open source software. Now, it is this dependence on open source software that makes it both powerful and vulnerable. Software supply chain is a complex mix of technology, people, process, and that introduces a large number of touch points. And for attackers, these touch points becomes the attack surfaces to infiltrate the software supply chain. Now, a crucial issue with the supply chain is that this chain of open source dependencies are outside the control of the software developers and the organizations that build the final product. Now, this limits their ability to improve the security of these dependencies and the infrastructure that hosts these dependency softwares. The reason why supply chain security is very critical is that compromising even a small component in this ecosystem can have a wider and catastrophic impact. To drive this point home, let us look at a few attacks on software supply chain. So these are some software supply chain attacks. There are actually a lot more. I just selected a few of them to show you the variety of attacks. So first one is event stream in 2018. So an attacker published a new NPM package called flatmap string with no malicious code. A month later, it was added as a dependency of the event stream package. And another month later, a malicious version of the flatmap string, which was a dependency, was published. And the issue was detected only after $8 million of the affected software was happened, and it affected a large number of systems. In 2020, SolarWinds attack. What happened was attackers injected a backdoor into the software update of SolarWinds. Now, SolarWinds is a networking software that is used by big companies as well as government agencies. Now, this backdoor allowed attackers remote access to thousands of systems across the world from every client who would have used the SolarWinds software. So the affected organizations included Intel, Microsoft, Cisco, and even a number of US government agencies. The third one is Kaseya. So attackers compromised this platform, infecting with ransomware, which then deployed together with an update of the software. So this ransomware spread to thousands of customer environments, and the attackers were able to extort more than 70 million from the affected customers. Code core. So an attacker infected the code bash updater, which is part of a code coverage testing tool that automatically sends customer reports. By injecting malicious code into the script, the attacker was able to eavesdrop on the code core servers and steal customer data. And the most recent one is exit utility backdoor. So malicious backdoor in the exit Linux utility was created, which giving backdoor access to, and that backdoor access actually gave remote execution privileges over some versions of OpenSSH on the target systems. Now, these are again, very few number of attacks that I have quoted here, but this should give you an idea about the variety and the impact of these attacks. So, touch points these are the touch points where the attackers can exploit vulnerable parts of the supply chains. And as you can see from the list on the left side, it covers the entirety of your SDLC. Now, on the right side, what you're seeing the attack vectors and how an attacker can exploit some of the vulnerabilities. For example, third-party components. So the malicious actors can target third-party components like libraries or frameworks and search for opportunities to insert malware into them. Compromise development tools. Again, procedure compilers, build systems, or other development tools can try to inject malware. Developer accounts. This is quite common. Malicious actors can try to exploit vulnerabilities within developer accounts. Could be in hosted code platforms like GitHub or GitLab. Compromise software update infrastructure. Now, again, actors frequently target this kind of in software update infrastructures to compromise and insert malware into software updates. Social engineering. Again, attackers can try to contact employees and domain audit and develop their security clearances using social engineering. So how do we prevent and mitigate this kind of attacks? 4 phases of it. One is protecting the source code integrity, which that is where everything starts. Code signing and protect source code integrity. There are a number of standards for signing and attestation of code and artifacts. Mitigating dependencies that requires that you know about the dependencies of your software and continuously monitor for the vulnerabilities. And for your build and deployment infrastructure, you can improve the security in terms of whether it is exposed to your internet or is there any open endpoints which attackers can exploit. Things like that. Securing the entire infrastructure it should always be a high priority for DevSecOps and DevOps. So for whatever we discussed so far, one key takeaway is that a number of DevOps and DevSecOps responsibilities revolve around the software supply chain. And protecting this supply chain will be a major part of DevSecOps responsibility. And one of the most important steps in protecting supply chain is to understand what is in your software, because if you don't know what is in your software, you cannot protect your software. So figuring out what are the dependencies that goes into your software is very important. And this is where software bill of material comes into play. So bill of materials is a common term. It's mostly used. It's used in many industries, even in constructions, manufacturing, and whatnot. So bill of materials is an extensive list of raw materials, components, and even instructions required to construct, manufacture, or repair a particular service. So there are manufacturing BOMs, engineering bill of materials, etc. But in the context of software and SBOM, for a software bill of material, include all software components that are used to make a final software product. The SBOM will introduce details of the software version, patches, dependencies, vulnerabilities, licenses, etc. Some of the key benefits of software bill of materials. One is component transparency. Once you have an SBOM software, it offers complete transparency into the components used in that application, which helps identify potential security vulnerabilities or licensing issues related to third-party dependencies. Vulnerability management. Once we know all the components and their versions and organizations, then quickly identify if any part of the software is affected by known vulnerabilities and take appropriate remediation measures. Think of the log for shell vulnerability. Any organization that had SBOM at that point in time would have been able to quickly protect them because they would know which all components in their software infrastructure would be impacted by the log for shell vulnerability. Compliance and risk. SBOM aids in complying with industry regulations and standards that mandate transparency and disclosure of third party. It also helps in evaluating potential security and legal risks associated with the software. And again, general supply chain security, it enables organizations to better understand and manage their software supply chain, reduce the risk for attacks, and ensuring that components and are sourced from trusted sources. Again, you don't just manufacture one software. You will have a number of software that are deployed. Some might be open source tools, some might be infrastructure tools. Any company would have a number of softwares, and in managing all of them and processing them, obviously you cannot process them in a usage humans, so which means it requires automations, right? So it is imperative that you should have standards for SBOMs. And as we can see, it helps you with interoperability and adopt industry best practices. Let us look at some of the standards in SBOM. So the current industry standards are Cyclone DS and SPDS. We will look into them in a bit more detail in the next slides. So in addition to these two SBOM standards, there are also a few other standards that help in naming and describing. So they are software IDs. It defines a structural metadata format for describing a software product. Common platform enumeration or CPE with a standardized method for disturbing and identifying class of applications, operating systems, and even hardware devices present in an enterprise's computing assets. Package URL. The URL is it's a URL string used to identify and locate a software package in a universal way. Most programming languages, package managers, packaging conventions, tools, APIs, and databases. So let's say you have a machine, whatever software is installed on it, whether they are RPM, Debian packages, or Java packages, anything of this. So everything can be represented using a package URL. So let us come to one of the SBOM standards, that is SPDX. So SPDX is essentially software package data exchange. And it was Linux software foundation that developed this in the early 2010s. So it focused mostly on compliance and licensing. And the latest version is 3.0.1. One thing about SPDX that is very comprehensive, it not only lists packages or its licenses, it also lists files used and code snippets sometimes. So this actually helps in getting a well-rounded view of what our components are there in your software ecosystem. And it has been around for a long time, from 2010. And it's already used by many industries and products, including automotive and the healthcare industries. For Cyclone DX came from OWASP. Anyone who is into security will know about the OWASP Foundation. And actually, their core focus on vulnerability and security. And this used quite widely in a number of software organizations. And the latest version is 1.6. So SBOM classification. So SBOM can be generated in various stages of your software development lifecycle and has different classifications and purposes. CISA, the US Cybersecurity Agency, classifies the SBOMs into 6 categories, as you can see. There's design, source, build, analyze, deployed, and runtime. And you can see the difference here. It's quite self-explanatory. So again, the software bill of material can be generated all these stages, depending on whether you're building a software or you just bought a software and things like that. But there are also other types of classifications for BOMs, like SaaS bill of materials, machine learning bill of materials, hardware bill of materials, etc. Let's go into a short demo of generating an SBOM in Cyclone DX format and then look into the data in the SBOM. So there are a number of ports which you can use for generating software bill of materials. So we are using a utility called SIPT, which is from the company Anchor, which is a security company. And what we're going to do, so there are, again, SBOM can be generated from any sort of packages, softwares, even just a directory within your file system. In this particular case, we are going to directly fetch the Alpine Docker image, we scan it and generate a software bill of material out of it. There is no additional software installed. This is the plain vanilla Alpine image. And again, if you see the CLI options, we are giving it the Cyclone DX JSON format. We save it into a file called alpine.cyclone.json. As you can see, it first the image, doing some cataloging of all the softwares, looking at file metadata, file digest, etc. It looks like it is finished. So let us start examining the JSON file. We'll start with the top elements that this file has. So that you can see schema, BOM format, components, dependencies, metadata, serial number, spec version. So if you go to the actual Cyclone DX specification that I had given in the previous slide, there's a lot more elements within the Cyclone DX format. But a lot of them are optional. If I remember right, there are only serial number and spec version which are compulsory, and everything else is optional. So this gives a lot of freedom for people to generate SBOMs as they require. But again, if you want to know more details about what each of these components mean, you can actually visit the specification. Now let us look at some of the basic information. Schema again points to the actual schema at Cyclone DX website. The BOM format obviously Cyclone DX, and the spec version is 1.6. Now the other things are serial number and version. So the SBOM standard mandates that there should be a serial number which can uniquely identify a particular SBOM file. And whenever, so let's say you are right now you have targeted Alpine Docker image. Right now, let's say after the Docker Alpine Docker image changed, and you have again generated an SBOM, then it should have a different version. It could be it will start from version 1 and version 2 and progress like that. So you most important things to remember: you have a serial number and a version. Now there is a metadata dictionary within the Cyclone DX. If you see here, it talks about the software itself and how it was generated. So the timestamp is the time at which the SBOM was generated, and the tools used for generating it. And who's the authors from air code, the utility name is Swift, and uses the version on web 1.0. And there's a component here. So this component actually discusses what is the software for which this SBOM is generated. And this obviously is Alpine, and it's a type container. And what you see here, BOM reference as a string. So in SiteBOM.dx format, a BOM reference is like a unique key or a primary key for any software component within that particular document. Now, you could use this reference ID to refer to this particular component in any other part of the same document. That is the whole idea of BOM references. You will see more BOM references in the coming portions. Let's look at components. Components are nothing but these are the actual software components that the SBOM will detected and then added into the SBOM file. So what you can see is that now it actually detected 15 components. Remember that Alpine is a very lightweight image and it has a very limited number of software packages. And that is why you are only seeing 15. It was a large Docker image with a bunch of files or code. This would be totally different. So we know that there are only 15 components. So let us look at what are the components that this file has. So as you can see, there are again 15 packages. And what I have listed is the package name and type of the package. So for SBOM, most of the packages are considered as libraries or dependencies. And it also detected Alpine as an operating system. So these are the 15 components within this SBOM. Now we will take a look at one of the packages called SSR client. So for this package, so there's a lot of information per package in an SBOM. So properties is one element which is quite long. We will see that in the next session. Before that, I want to show the rest of the components here. So if you see here again, there's a BOM reference, which is the unique key for this particular package called SSR client within this document. So that is what BOM reference is. And you can see that it has a particular format. The type is library, obviously, and the publisher is the author of the software. And the name, version, description, everything is gathered here. And one of the important things is it also lists licenses, and it is a GPL2 version. One thing you know about this structure is that it says licenses, not license. The reason is, for an open source software, it might be built from a bunch of other softwares, and they might have varying licenses. And that is why the provision is therefore adding a bunch of additional licenses that might be applicable to the software. And if you remember, we have discussed known SBOM standards, CP, PURL, etc., SWD, all of them. This system actually uses CP and PURL for referencing to some of these components. External references, whenever a tool can find some information about where this software came from or where the documentation site is or whatnot, it will be added as an external document. Now let's look at the property of this particular package. So there's a long list of items. We will look at a few. So again, how was this package discovered? APK DB cataloger is a component of the SIT utility. And as per utility, will have a bunch of catalogers for different type of softwares, and this actually found out that it's an APK. And the package type is APK. And some of the other important things are the size of the package, some of the dependency list, and what it provides, etc., and the version. Things like that. So I talked about multiple licenses, right? And the package that we saw had only one license. Let us see another package. This is Bash key. And I took it from another SBOM that I generated earlier for Ubuntu image, the basic Ubuntu image. And the license we are looking for is for the package Bash. You see here, Bash has a whole bunch of licenses attached to it. PSD, GFDL, GPL, latex to it, MIT line, all of them. So that's why I was talking. That is why when you are looking at license purposes, not just security, as well also helps you with license compliances to see whether you have possible legal issues in terms of license violations or everything like that. So that is why this licensing part is very important. Again, so we looked at components as a top level element now, and there is another top level element which is dependencies. Dependencies, as the name suggests, is the dependency between the components that we saw already. Now there are 10 entries for dependencies here. And what we are going to do is pick just one package for the time being and see what are its dependencies. You see here, again, there's a reference. So basically, we pick the dependencies of the SSL client package. And what you can see is it depends on 3 other packages. And if you see here, all of them are BOM references, which means you can find these packages within this SBOM file. Now, since you know what packages are in your SBOM and what is the versions, it's always possible to look up into external vulnerability database and figure out whether this package has vulnerabilities. And that is one of the advantages of having an SBOM. And to do that, we are using another CLI from the Anchor company. It's another CLI to which you can feed this SBOM file, and Anchor will go online. So Drive will go online, talk to a few vulnerability databases and figure out is there any vulnerability in this SBOM packages listed in this SBOM. So let's do it. Alright, created a report called alpine.type.jsm. So all the whatever response it gave is here. Then what we're going to do is, I know that it has found a few matches. So I'm just picking one of the matches and some of the information about that vulnerability here. Give me a second. Sorry for that. Because there is a slight problem. Troubleshoot display. Alright, my bad, I think there was some system was hanging for a bit. But you can see the result now. Oh, the vulnerability detect is for the package the vulnerable version is 3.3.2-R0 and the vulnerability is CVE 2249143. It has a medium vulnerability category, and this version is basically showing that this is the fixed version of this particular package without this vulnerability. As you can see, this is only limited information. If you look at this file, actually, if you generate this file, you will see there is detailed information about what is the vulnerability, what are the artifacts impacted, etc., etc. I just shared some information to show you what it can do. All right, and again, you could use AI tools. You will get similar results, and this helps you in finding out what packages in your system has what vulnerabilities and mitigate them. Now, just to show you about the dependency, I will do one more thing. I am picking up all the dependencies from this SBOM and plotting it as a graph. All right. As you can see, there's a lot of dependencies that as you can see. So if you see a Pika tool system has a bunch of dependencies, I think base layout has 2 dependencies, SSL has 3 dependencies, like that. And the dependencies might be depending on some other dependent software. So there is going to be a multi-level dependency here. And just to show you that, and let me actually pick up package called Alpine base layout from this SBOM and show its dependencies as a graph. Right. So as you can see, Alpine base layout is the package, and it has 2 dependencies. One is Alpine base layout pattern. Sorry that it's not showing the entire package name here, but that is one of the dependencies. And the second dependency is busybox bmessage, which in turn has a busybox dependency, which in turn depends on the muscle library. As you can see, just to show you that when you have a package, the dependency is multi-layered. And with this dependency information, you can actually plot the entire dependency and figure out if your software has some upstream dependency or in some way a level dependency, which could have vulnerability or other legal issues. All right. So that is the power of having an SBOM. Now with this, let me wind up this demo and get back to the presentation. What should the DevSecOps do to adopt them? See, SBOM is a new topic for most of the engineering. Understand them first and then assess and document the use cases within the organization. And if necessary, evaluate this to the rest of the organization. Once you do that, evaluate the tools for creating and managing SBOMs. There are a lot of open source as well as vendor tools. Many of them are SaaS products. So once you pick the tools, integrate them into your software development lifecycle and automate SBOM generation. You should have tools that will help you save the SBOM data and analyze them. And also remember that this is not a one-time task and should be part of your SDLC and continuous process. So to analyze the data and make reports and share it with the right stakeholders, might be your engineering counterparts, leadership, or security team. And also set alerts and reports on vulnerabilities, license components, etc. so that your security posture improves. With that, we are coming to the end of this presentation. If you would like to know more about the SBOM, these resources will help you. So the OS for authoritative guide response is extensive, and it will give you a good idea about the segment format as well as the general information about SBOM, how to go about adoption, etc. And if you want to know about SBOM tools, SiteOnDS Tool Center is actually a good starting point. Of course, it doesn't cover all the tools that is out there, but it gives just a good starting point. I hope you were able to get some value out of this presentation, and thanks for listening.